Levy's 1948 construction of Brownian motion. So we define Brownian motion as a continuous time process which satisfies the following points. So it starts at the value at time 0 is 0. The increments over the disjoint intervals are independent. So for any u that's smaller than t, smaller than s, smaller than j, the increment between b of t minus b of u is independent of b of j minus b of s. The increments are normally distributed with a mean of 0 and a variance of t minus u. So we have bt and bu. Their difference has a variance of t minus u. And lastly, it's a continuous process. B is a continuous process, although that's not always required as part of the definition. Billingsley, for instance, does not require that. Then the concept of a level n. A level n splits the interval 0, 1 in this case, because the construction is going to be on the interval 0, 1, into two n pieces, each of length 2 to the negative n. Then we define a refinement as going from level n to level n plus 1. So you go from having two n pieces to having 2n plus 1. So at level n equals 1, we're going to have two intervals. The interval from 0 to a half and from 1/2 to 1. The refinement of that is going to have four intervals. At level n equals 2, we have the interval from 0 to a quarter, from a quarter to 1/2, from 1/2 to 3/4, and from 3/4 to 1. The actual building blocks used in Levy's construction are defined as follows. At each level n, we define a umn to be the increment over the interval from m minus 1 times 2 to the negative n, m2 to the negative n. Additionally, we want all of these umn to be distributed normally with a mean of 0 and a variance of 2 to the negative n. Then at level n equals 0, we have the interval from 0 to 1, which is the full length interval. We don't split it up into any pieces. We have the variable u1, 0, which is normally distributed with a mean of 0 and a variance of 1, which then fixes b at level 0 at time 0 to be equal to 0, as per the definition of Brownian motion. And at the endpoint of the interval, it's equal to u1, 0, which is by construction. As we can see that the difference between these two is normally distributed with a mean of 0 and a variance of 1, which is this property. So at the next refinement level of n equals 1, we want to have two increments, each of variance 1/2. This is to satisfy the third property of the Brownian motion process. So to achieve this, we introduce a variable v, subscript 1, 0, that's normally distributed with a mean of 0 and a variance of 1, so same distribution as the u. And crucially, it needs to be independent of the previous variable u, subscript 1, 0. To continue, we define u1, 1 as being the sum of those previous two variables or increments divided in half, and u2, 1 is equal u1, 0 minus v1, 0 divided by 2. So the reason we introduce this is because we want to have our construction hold at each refinement level. So we check the properties. We want these two pieces to basically give us back the first piece. So u1, 1 plus u2, 1 equals u1, 0. This is satisfied. We can just write this out. So this is u1, 0 divided by 2 plus v1, 0 divided by 2. u1, 0 divided by 2 minus v1, 0 divided by 2. These two cancel out, and we have 2u1, 0 divided by 2 So this does indeed give us back u1 comma 0. Next, we want to check that the variance of each of these new increments, which we constructed by splitting the interval in half, satisfies a variance of 1/2. So the variance of u1 comma 1, we can just write that out. The variance quadratic operator, so 1/2 goes out of the variance squared, so it's 1/4. Variance u1 comma 0 plus variance v1 comma 0 plus 2 times their covariance. But by construction, the covariance between u1 comma 0 and v1 comma 0 is 0. So this just gives us variance of this is 1, variance of this one is 1, 1 plus 1 is 2, divided or times 1/4, that's 2/4, equals 1/2. So indeed, each of these new increments does have the required variance. So next, a fact about Gaussian distributions. If two distributions are Gaussian and their covariance / correlation is 0, this implies that they are independent. We can check the covariance between these two newly constructed increments as just being the expectation of the product of them, since they have mean 0. So this is equal to 1/4 the expectation of u subscript 1 comma 0 squared minus v1 comma 0 squared. Because again, they have mean 0, their second moment is just their variance. So this is variance of u1 comma 0 minus variance of 1 comma 0, or variance v1 comma 0, which is just 1 minus 1, which is 0, times 1/4, still 0. So just as for refinement level n equals 0, now at refinement level n equals 1, we have two intervals from 0 to 1/2 and from 1/2 to 1. So at the start, Brownian motion refinement level 1 is just equal to 0. At the midway point, it's equal to u1 comma 1, which is true by construction. The difference between these two is normally distributed with a mean of 0 and a variance of 1/2, because we proved that u1 comma 1 has variance of 1/2. And then at the end, or at the end of the interval, the Brownian motion at refinement level 1 of 1 is just equal to the sum of these two, which again is true by construction. The difference between this one and this one gives us u21 comma 1, which has a variance of 1/2, which we again proved. The procedure is as follows. For the next refinement level, you define again vm comma 1, normally distributed, mean 0, variance 1/2. Split the interval, so we get again 4 pieces now of these u's. So now these 4 increments each have a normal distribution with a mean of 0 and a variance of 1/4. And then the points are just given as, well, you can just plug them in, but k/4, the sum from j equals 1 to k of these 4 pieces uj comma 2, for k is equal to 1, for k is equal to 0 to 4, and then continue this process infinitely for the next refinement. So what's left is to check for actual convergence of these Bn processes to the actual continuous time process Bt of Brownian motion.